I'm Andrew. We're going to talk about AI and security products. And before I even get started, not an expert on AI or like really even close, but the only reason that I feel even remotely qualified to talk about this is that we have shipped an AI-powered product at Grey Noise, and so it's like, look, there's some takeaways that we've kind of experienced going through this, and I'd like to just talk about some of that with the folks in this room. I'm going to try to be like sort of broadly abstract at the high level and then delve into some ultra specifics just for like one or two little examples, and then I'm hoping to make some of this interactive and maybe chat back and forth with you guys if I can. So with that, and I did not have our design team even touch this presentation, so this is going to be disgusting, but it's full of content. So for what it's worth, we're going to abstract this stuff down a little bit just to blank detection and response technologies, okay? So when I say that, I mean like endpoint detection and response, network detection and response, whatever. Like all of them are kind of doing some kind of a thing happens, and I want to try to, you know, synthesize that into some kind of block decision, okay? This is not anything new, right? Endpoint detection and response, network detection and response, all these things are just basically looking to see, hey, when something happens, do something about it, right? And it's not every security product, but pretty much every detection and response product is going to have some kind of flow like this a little bit, right? This is the agenda that I'm going to be talking about here today. I'm going to just try to blast through this in no particular. I'm going to try to blast through this as quickly as I can. So, again, like. Let's talk about like let's work backwards from where we want to go and in like this sort of ideal scenario, okay? Right now there's all kinds of complexities and complications. There's like a ton of different steps in between a thing happening, it getting sucked up into a computer somewhere, and then a decision being made that's ultimately going to yield 99% of the times a block decision, right? Like when you really think about like the product or the output of like 99% of really actually automated detection and response products, it's probably going to end up with a like, hey, don't let this thing happen, right? Like the rejection, like no, right? Sometimes it's going to be an alert, hey, this thing happened. Sometimes it's going to be, hey, you should be worried about this. But where a lot of stuff ends up going is just, it's going to have to turn into automation at some point, and it's going to have to turn into an automatable, like, and then prevent this from happening every time into the foreseeable future. So again, grossly oversimplifying, but the dream here is instead of going from like telemetry that gets zapped off into a place and a bunch of analysts looking at it and then jiggering things together and writing rules on it, and then ultimately it becomes a report that somebody reads, they apply that report to their network, they find things that shake out of it, and then they make block decisions on it, right? How much of this can we skip? How do we go from just telemetry to like a useful report or a automated block decision, right? So again, I'm going to abstract this a little bit and let's explore it. So right now, I kind of talked through this a little bit at the beginning, but endpoint and detection and response products and network detection and response products as well sort of follow this sort of flow, right? Like collect and enrich and analyze and process data for a thing, okay? And that thing can be an IP, it can be a file, it can be a URL, it can be a website, it can be a domain, whatever, right? But it's a thing, right? So again, abstracted to the thing. Now, collect data from wherever, enrich the data with some other data, great. Do some kind of filtering and some normalization, great. Then let's make a decision or let's make a verdict on whether or not we think this thing is, I don't know, good or bad, or forget about good and bad, but like what about just, I don't know, like, well, what kind of domain is this? What kind of website is this? What kind of file is this? What kind of program is this? Before we even get to good or bad or anything like that. And then eventually it's going to be a decision, right? Some decision is going to be made, right? Like, this thing is bad, don't do something about this. Or this goes onto a block list or something like this, right? Does this make sense so far? Does this sort of resonate with you? Okay, good, fantastic. Stop me if it doesn't. So now, in this case, these things that I've highlighted in green are actually some of the areas where it seems that AI and LLMs, specifically large language models, are actually super useful. They're good, actually, at doing these kinds of things where humans are actually not quite as good. They're just a lot more efficient, right? So these are some of the places, and then you could argue that you could highlight this whole second thing in green, but it's more complicated than that in practice. So again, we're gonna just kind of keep sort of talking through the specifics here. So before I even get too terribly into it, I want to talk just a little bit about LLMs. Again, I don't know much about AI, to be honest, but grossly oversimplified, large language models are just huge text models where you can give it an input, and it's using kind of like glorified it's using complicated math to look up into a big file that has a bunch of text that it's trained on in order to give basically a somewhat predictable response back. It can do some kind of it has some ability to apply reasoning. It has some ability to apply style. It has some ability to do things like this. But ultimately, at the end of the day, large language models they're really good for understanding stuff. They're good at recognizing patterns. This is great. It's good at, again, automated reasoning. So large language models don't have moods like people do. So they're going to be repeatable in the way that they apply their biases. There's still going to be biases, but it's going to be relatively repeatable, relatively deterministic. And then text generation, right? It's good at then writing. LLMs are a lot better at typing than people are, right? So this is great. The things that are kind of introduced to the world of cybersecurity products, detection and response products, is translating data or doing a little bit more nuanced analysis or something like this. These are some of the things that LLMs are actually really, really good at. What are the challenges that stay the same for the foreseeable future? What isn't going to change at all with AI and with large language models and security? Well, getting the data, right? LLMs don't help you get the data in any way. You still have to do that. That's a whole massive part of the problem. The quality of the data, cleaning the data, right? If you want to build automated security products that are going to be making decisions based on data, and the data sucks on the way in, then your verdicts are probably going to be bad too. And then finally, just practically speaking, you can't just run every single thing that happens on a computer through a large language model. So you have to make it small and manageable before you use an LLM, right? So it's really, really, really easy for people to, I think, kind of lose, it's really easy to look at how exciting language models are and how exciting AI is, because you kind of want to live in this world where you're like, man, if we just blast absolutely everything through this thing, it's going to tell me all these right answers all the time. And that's not true, just because it's computationally infeasible, right? There's just no chance. That's not going to happen anytime soon. It's going to be a very, very long time before the world is even remotely capable of pushing everything through language models or really anything at all like that. So you got to make it small. You got to make it small before you blast through an LLM. And I'll talk through that a little bit more here in the future. So what actually changes? So these are some of the things that, practically speaking, at Gray Noise, we've kind of observed, and I'm saying gray noise, but a lot of this is really just me personally. I've noticed that language models are really, really good at doing stuff like this, right? Translating between ontologies, okay? This is actually a really sort of screwed up problem in cybersecurity products, in building cybersecurity products. As a person who runs a company that builds cybersecurity products, every single different risk ontology or risk framework and every single other vulnerability management framework or vulnerability management standard, data files, data standards, I guess you could even say different versioning schemas and different rule syntaxes and things like this. They're all kind of trying to accomplish this small handful of the same things. And everyone is well-intentioned who comes up with a new spec or a new format for something, but it sucks to develop products on, right? Because there's 10 different standards that you have to implement for everything, and it's not fun. The good news is, again, I've got in here, hey, I want to take something and go from, I think I actually have an example of this right here. Hey, look, this is just some dumb stuff that I'm doing just to show how insanely easy this stuff is. Dumb example. I just grab a Suricata rule off the internet. Oh my God. And I go to and I go to ChatGPT and I'm like, hey, rewrite this in Zeek. And it's like, first I'm going to complain about it a little bit. We actually use a different approach. Hey, shut up. Okay, just do it. And it's like, okay. And so then it does it, right? It rewrites the thing in a format that makes sense for Zeek, and it doesn't, it just blasts it out. Again, language models, they don't get tired. They usually don't complain, but they don't get tired. They have a really good memory, and all I'm doing is saying, like, take this thing from this format, apply it into this one. And if you're terse enough, and if you leave as little, and if you beat the machine into submission, it will do exactly what you say it will do. It will do exactly what you want it to do, okay? Another silly example of this is, again, this is really silly, but this is just, I uploaded a file off from my Mac to ChatGPT. I uploaded the ls binary from my computer, and I was just like, hey, ChatGPT, this LM right here, analyze this file for me, right? Basic file analysis of like, hey, this is a thing that I want to know. I have some basic questions about. Can you pull this thing apart for me? A lot of the stuff that we're sort of used to doing in VirusTotal and in other products and stuff like that. And so again, language models are actually pretty good at stuff like this. This is pretty cool. So going back here to the stuff that LVMs are good at and what actually is going to change with the implementation of language models and AI in cybersecurity products, it's really easy to go from a snort rule to a Suricata rule now, right? It's really easy to go from, my analysts don't use SQL, they actually use Kusto, they use KQL, so just in a one-time job, we're just gonna blast this over and then everything automated into the future, we're gonna translate over into this thing. Doesn't guarantee that the thing's gonna work. You still have to do all your QA stuff, and I'm going to touch that a little bit later. But these things are actually all really easy now, and I would really encourage people who are working with any kind of data-heavy environments or who are building security products or anything like this to really investigate like how actually relatively easy it is to translate from these different formats to really, really quickly be able to move something from A to B. This is a really unsexy, soft underbelly to a lot of like the threat intelligence industry and like a lot of the I guess endpoint detection and response, network detection and response industries where there's all these different like slivers of problems that only people can do, but LVMs are actually pretty good at them. So it's pretty neat. They help us answer stuff like, what is this file, right? And it doesn't have to just be like, is this file bad? That's very hard. But what is this file? Tell me what this file is, right? Tell me what this network traffic looks like. Tell me what this code does, right? These are the kinds of things that LVMs are just better at than humans, right? So this is really cool. They're not good at everything, but they are better than us at some things. So some other practical examples, and the one that I'm actually the most excited about, something we built at Grey Noise, we released it earlier this week, is called SIFT. So this is what a Grey Noise tag looks like on our side. Wait, real quick, do you guys know Grey Noise? Raise your hand if you know Grey Noise. Everyone in the room knows Grey Noise. So like on our side, this is what a Grey Noise tag looks like. Like this is what we write that becomes this. It's, okay, and a person did that, and we're taking sensor data, network traffic that is hitting all of the Grey Noise collectors. As a reminder, we run thousands of honeypots of Grey Noise. They're just computers that are sitting in a bunch of different places, and we're logging all of the stuff that hits them. We're logging every single thing that touches them, and then we're writing rules on that data so that we can turn it into something that makes sense so that people can make better decisions in their security operations centers and using their security products. So this is what we do, right? We write this thing, and this is what it yields. So a lot of work, right, to get these things right, and doesn't even necessarily yield a ton of data. But now, and this is a lot uglier, but it's a lot better format. We have this thing called SIFT. This is a thing that we shipped this week, and this is actually available right now. If you have a Grey Noise account, if you want to check it out, you can go to sift.labs.greynoise.io. It's free, so you can have a Grey Noise account. You don't have to give us a dime for it, but you can go there right now. And it's pretty cool. So what it does is, you can see here that there's like actually way more detail in a lot of this stuff that we're doing, but a computer did this, right? Like a person didn't write this. A computer looked at network traffic, and it just, all we did is we didn't say to the computer, hey, tell me everything about this thing. What we're doing is we're making the traffic, we're making the data smaller first, and then we're offloading that part that LVMs, that language models, that AI is good at. we're actually offloading that over to the language model. So I think I actually have a short, yeah, this is the too long didn't read of SIFT and how it actually works. What we're doing is we're basically saying, hey, starting with Gray Noise's raw data, Gray Noise's raw telemetry, all of the data that we see hit all of our sensor network every day, which is between 100 million and about 1 billion messages a day, of which, quite a few are going to be HTTP requests, and then quite a few are going to be web requests, and quite a few are going to be just random other stuff. So basically, starting with this, we're saying, what are today's clusters? So that means not everything that hits the internet or not every bit of network traffic that blasts across people's networks is, it's not all unique. It's some pieces of it are going to be unique, but the traffic is going to kind of cluster together, right? So what we're doing is we're saying what are today's clusters? We've got this, 7,000 clusters of things that all look relatively similar that are happening. Maybe the user agent is a little different, or maybe the request is a little different, maybe this GUID is a little different, whatever, who cares? And we're saying, which of these clusters have we never seen before? Again, let's make it smaller. So what's the net new stuff that's hitting the whole internet today that's never hit the internet before? Which is a much smaller list of things. And then we reach to the language model, we reach to AI, and we say, okay, cool. Of this 100 things that have never happened before, what is it? What is this thing? And just write me some really basic analysis of this. And the cool part is, we still can't really go straight from this to a block decision or something like this, but we can. We have taken a huge problem and we've made it a whole lot smaller. So again, this is the analysis that we've gotten out of just this one SIFT. This was, I think I pulled this out from yesterday. So this is yesterday's SIFT. This was the second one, and you can see here it's hey, here's some examples of this thing. These are some basically kind of tags or annotations that we're going to make around this. Okay, that's good. It looks kind of like these things, whatever. And then this is my human analysis to it. These are the vulnerabilities that we think it might be related to. We're not sure. And then you can flip it back around and have it actually write rules for you as well. So then once it knows the thing, you can say, cool, and write me a Suricata signature and some SQL to be able to find this everywhere else for people who don't use Gray Noise, right? So hey, here's a bunch of rules that you can use anywhere, right? These are the kind of things that language models and that AI is really good at, right? It's really bad at a lot of other stuff, but it's really good at things like this. So at a high level, in no particular order, I'd say I would really, really recommend if you are a product manager at a detection response company of any kind, or if you are a buyer of a detection response product anywhere, or a user of a detection response product anywhere, or you even have kind of your own thing that you're building. These are just some sort of tips that I've got in very real practice to apply for actually being able to get something out of AI and security products. And the first one is you can't do it with everything. You're gonna have to shrink the data before you crunch it over into the computer, before you ask the language model to do something with it. You need to make it smaller first. The second thing here is that you do prompt engineering. If you don't know what a prompt engineer or what prompt engineering is, I'll just explain it real quick. Prompt engineering is basically where instead of just asking a language model write me a haiku about cybersecurity, what you're doing is you're actually you are a poet and you are you can only speak to me in this way. And it's and then you're okay, and every other letter you're gonna do this. And so it's basically you just beating the machine into submission to do the thing exactly as you want it to do, ultra specifically. So you wanna do this, it's your friend. The state of the art in this is pretty rough right now. The state of the art of actually implementing prompt engineering right now kind of sucks, but whatever. You don't want to think about giving LVM any big problems to a language model. You want to give small, discrete problems to a language model. So think about kind of like functional programming a little bit, where you really kind of want to think about like abstraction to like, I don't want to write all this business logic in this program. I want to split it up into a bunch of functions that take an input and do an output. And I want those to be as small as possible. You kind of want to implement that same type of thinking when you want to use language models for stuff, because otherwise things are going to just spiral out of control. They're going to run away real fast. You have to test extensively because language models like to make shit up sometimes. Excuse my language. They like to make things up sometimes. And so you have to know where things are going to break and where things aren't. You have to know the language model's biases before you do stuff, because every language model has a tendency to lie in a similar direction or to have similar kinds of lies or things like this. You have to leave a human in the loop, blah, blah, blah. I really recommend leaning into, as much as you can, the problems that humans are bad at. Lean into those with AI and LVMs. Things that are subjective and squishy. What is this? Right? That's the question. What is this? What do you think this thing is? Right? Because maybe if it's wrong, it might be wrong, but when you're hooking up machines that are doing this, you'll be really impressed with, more often than not, the context that things are going to actually give you. And then if you're building, so a Gray Noise is basically a giant data labeling machine. Like, that's all it is. We're basically taking thousands of inputs from thousands of places, and we're just applying as many labels onto that data as we can that's useful to people, and we're giving that labeled data back to people. So part of that means that, we have standards, we have a tag ontology, we have classifications, we have all this kind of stuff that we do to make sure that our data is nice and clean. So if you're building stuff using AI and using language models, then you're going to have to, you may end up just wanting to teach it about your ontology. When I actually went back, this is something fun that we do here. This rule, this SQL, select star from HTTP payloads where blah, 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 blah. This rule back here is written to work against our internal data model for how we actually analyze data at Gray Noise. We run everything through a bunch of databases that have a SQL indexing built on each of these different data fields. And so we teach the language model about our internal thing, and then we make it produce things for us in our internal ontology. These are the kinds of things you really want to lean into, that LVMs, that language models are really good at. Again, don't give it big, hairy problems like you can't, there's a lot of steps between here's a bunch of internet telemetry, tell me what's useful. You really want to try to chip away at these things as much as you possibly can and translate them into ontologies that are useful for you. And then the only other thing that I'd add as a tip is like the state of the art for actually doing relatively basic things like daemon programming, right? And like actual services that are running all the time and is actually pretty bad for language models right now. So you might have to end up implementing a lot of this stuff yourself, just kind of as a heads up. But yeah, I mean, look, that's basically it in a high level. Like to go back to this, like language models are actually very useful. But the state of things right now, you can build and ship stuff with this right now. We have this thing, SIF, that we're doing is outperforming our own analyst team. So at Gray Noise, we have we shoot to, historically we've released I think maybe last year we were doing something like 0.5 or 0.6 new tags every day. So a new Gray Noise tag every other day. That was kind of the maximum throughput of our team. We're at about a tag and a half a day now because of SIFT. Our analyst team is actually able to grind with much more specificity, with a lot more velocity, looking at process data that's come through LVMs, language models. We've actually achieved a lot more velocity. So now we're actually able to produce tags. We've almost doubled our throughput with just this, and we're finding that more and more SIFT is basically noticing things that we're not noticing. And so we're starting to feel a lot of the places where this is actually useful and not. The places where I'd really recommend that people lean into the most is the soft and the squishy, right? What is this? Tell me about this thing. Tell me what this thing looks like. Describe this thing to me. And then finally, like, the goal is this. The goal is to go from raw telemetry data, some kind of series of nerdy stuff, an explainable decision or a report. You gotta work backwards from what products do. And we like to think in security that like, you know, we're doing all this like, especially when you build products, you like to take a lot of pride in like how cool and advanced and sexy and all this cool stuff that your report's gonna do and all this stuff. But at the end of the day, we're here at a conference that's built around security automation, engineering, security engineering, et cetera. You gotta just admit, like 99% of the stuff we do is gonna turn into a block, it's gonna turn into a block rule somewhere. Like that's what it's gonna do. It's either gonna do that or it's gonna be a report that someone else is gonna read they're gonna apply onto some data that someone's gonna turn into something that's gonna be a block rule, right? That's what it is, right? And so you just lean into that, right? You wanna lean into that and you wanna say, well, what steps do I have to take from telemetry to a written report or a block rule? What are the steps that I can take? This is the dream. The dream is that you just feed the raw data from the machines and you get these verdicts that other machines can eat and make decisions based off of. Because that's kind of the direction that the world's going. So anyways, I think that's it. So more than happy to answer any questions if anybody has any just on using language models of gray noise or anything like that. Yeah, John, what's up, dude? I'll yell it back to you.
All right, yeah. Do have. Sorry. So I got two. The first one is, and you can just say OpenAI, but what really unlocked like LLMs for you recently that made you experiment with this even more so than what AI was capable of? Yeah.
OpenAI. And then so at the very beginning, OpenAI came out, and we'd already built. So there were years of development and of R&D that led just up to that clustering part. Like if OpenAI became a thing 5 years ago, it wouldn't have changed a thing for us specifically at Gray Noise because we had not figured out how to make the data small enough and manageable enough so that we would even be able to take advantage of this. Our OpenAI bill right now is like, it's like $15 a month or something, and and it would have been $1 billion a month then. The biggest thing is just that we had to end up wrapping our hands around our own data because I don't want to wash away the problem or wish away the problem. It's a really, really, really hard problem just to go from all your data to all your data but smaller. That in and of itself is a very challenging thing to do. So we built on top of a bunch of research, which was hey, let's do an HTTP classifier, cluster classifier. How about a binary one? How about this other one? Now let's try to figure out the right sort of thresholds of how do we do this. And then, so there's a lot of work went into just that first part. OpenAI was the reason. And then as soon as we prototyped this for the first time, we introduced as a very real risk of well, what happens if OpenAI just changes their rates? What happens if they get rid of this plan? What happens if they get blown off the face of the planet? What happens? So we did end up having to diversify to a bunch of other LVM providers and even run the cost of what it looks like for us to do it ourselves. But yeah, that's the short answer.
And then the other one was, do you have an example of something that you're just shocked it found that you didn't think existed on the internet? Can you go into that?
Yeah, so we back tested the crap out of this thing on all historical Gray Noise data to see if it was able to find things that we knew happened or to see when it would have found things and to basically compare it to our analysts. It found Log4j, it found Triplegeddon, it found it found the Citrix bug, the Citrix bugs that have been coming out. It's found all of these things, and what's crazy is we've increasingly, I don't want to make this too much of a SIFT brag fest, but we've increasingly found that when someone says what is SIFT or what is this thing in SIFT, we defer to whatever it said instead of us explaining, because we're we don't know. We look at this thing and it's we read the description of what it came out with. Oh yeah, this is right. We have found that it is less error prone than we are, which is wild. And then the places where it does trip up a lot is it's insanely good at repeatably, reliably figuring out describing data. What it's really bad at is doing good severity levels. So again, these are the places where things are good and bad. Computers are insanely good at pattern matching and things, and doing kind of like, broad, like hard, heavy lifting, data heavy lifting, and remembering lots of stuff. But then when you're like, how big of a deal is this thing? And it's like, how big of a deal is a connect request to your web server? 10 out of 10. You're like, no, it's not. Right? No, it's not. But what I would, this is maybe going to sound kind of silly, but when I see things like that, I'm like, yeah, but, in a world where we only use classification levels in order to make something make sense to a person to evaluate whether or not doing something makes sense, like, who cares if sometimes the risk score is wrong in some of these things? This is something that our silly brains are so used to, but computers don't work the same way. So, anyways, for what it's worth. Any other questions? Herr Koopman? You could just yell it if you want.
I'm going to make him use the mic. His voice is very quiet.
Fair enough.
Very, very quiet.
I think I agree with pretty much everything that you said. I tend to agree with
Thanks,
pretty much
man.
everything you say.
Appreciate it.
And that's all. No.
All right, see you guys.
One thing that came to that kind of I thought about while you were talking was I almost feel like LLMs are so different I think you can wrap LLMs under AI, and under like what we thought AI was in the past and what was sold to us as AI from certain vendors. I almost feel like we have to kind of think, and we have to kind of readjust what we mean with AI, because I think about this previous generation that vendors tend to put into their products. That was just a bunch of statistics usually. That was just, I analyzed one of those that we were looking into. Not a previous employer of mine was not interested in probably acquiring a company that said they did AI, right? And so I happened to look into what they did, and it was all just Z-score thresholds, and you wonder, why does this run on a Raspberry Pi? I don't think this is AI, and I feel like this is so different to what was sold to us as AI in the past that we almost have to kind of get out of that mindset of like, oh yeah, now it costs double and it's just anomaly detection, to like, no, this is actually something that can provide some real value, and I think measurable value as well, as in that just saves us a lot of time, like what you've seen with SIFT and your analyst performance and all of that. I really, really think even for the people who are skeptical of AI and have been disappointed in the past, this is something new. And every time I use OpenAI, and I use it all the time, I give it the prompt, I guess, is that what you would call it? I give it the prompt, and it just does it. And not every single time, but very often I just sit there and I believe I understand computers and how they work. And every time I'm there, I'm like,
nope.
How did it do that?
Nope.
Why? How does it know that? Why can't it do that?
Because it's so hard to wrap your mind around. But this is just like, it's like a dude with a really, really, really good memory who sucks at everything other than like regurgitating impressions of stuff back to you. And he remembers everything that's ever happened, right? But he doesn't understand it necessarily, right? But he does remember everything ever. And so if you're like, what is this thing? Then he's seen everything that's happened on the internet ever, and he's going to tell you better than you would ever be able to figure out what the thing probably is. I too feel the appeal of on one hand, I'm going to try not to be too long-winded because I know I only have 5 seconds left. But on one hand, we do need to rethink AI, how we think about AI. I am super excited about AI as a longtime computer hater. I am super excited about AI, specifically with solving a lot of these gross underbelly problems that a lot of the security product industry is built around a lack of solution to. What is this thing? If you were to go back in time 5 years and you were to start a company that was called is this a marketing email or not? If you were to start that company 5 years ago, it would be, we have no idea how much money it would be making, but it would be making so much money right now, right? Just that one thing. It's like, look, we can't do anything other than tell you if something is a marketing email or not. It's kind of like that, but with all of these different distinct problems in security that are all of these reasons why we can't do other things. So that, I could go on about this forever, but I agree with you, Leonard. Yeah.
Thank you.